Okay, we've got a mess of examples to work through. I think we had a good introduction in the last class. Um, we're still working on the law of sines here. So let's get right into those examples. If the given angle, when only one angle and two sides are given, when that given angle is acute, you could have 0, 1, or 2 triangle solutions. And we know what they are. With this situation, there is no triangle and no solution. With this one, well, this is a right triangle. It's not an oblique. And we can use the standard right triangle stuff with that one. With this one, of the two given sides, this one is longer than the height, but it's shorter than the other given. In this case, we have two triangles. Same situation, this side is longer than the height, but it is also longer than the other given side. In this case, we have one triangle. If we have an obtuse angle, and this side is shorter than the one adjacent to the angle, we have no triangle. If it is longer than the one adjacent to the triangle, then we have one. So what's the situation we have here? We have an acute angle. The side opposite is quite short, but we really don't know that it's shorter than the height. At least I can't tell. Let's go ahead and try this one and see what we get. We're going to have the sine of 62 degrees divided by 5, the opposite side. That will give us the ratio that we're going to use here. So I'm going to turn on the calculator and make sure I'm in the proper mode, which I rarely am, maybe never am when I first start. Degree is what we want. Now I'm going to find that ratio. The sine of 62 degrees divided by the length of the opposite side. Okay, it's 0.1766. 0.1766. Now I can figure out what beta is. Since this is shorter than the other given, it's possible that I have two triangles. It's also possible that I have none. We'll know shortly. Okay, so the sine of beta over its opposite side, 15, has to be equal to 0.1766. So we know that the sine of beta is going to be that ratio multiplied by 15. So the sine of beta is 2.65. And what do you have to tell me about that? Impossible, right? So no solution. Example 4. Let's find the ratio here. The sine of 31 divided by the length of the opposite side, 22, 0.0234. 0.0234. The sine of beta over 9 equals this ratio. And we're going to take a look at that. So we multiply that ratio times 9. Oh, that looks okay. So we have the sine of beta is 0.2107. Sine of beta is 0.2107. Given the ratio and not knowing the angle, what are we going to do? I'm going to switch colors here because I'm going to have to work up here, I think. Guess I didn't look ahead well. We're going to do arc sine of this ratio to find out what the acute angle is. Well, okay, second function sine, arc sine I mean, 0.210697. Oh, that's enough. Okay, it says that beta is 12.16. Let's call it 12.2. 12.2 degrees. Okay? 12.2 degrees. All right, here's another one. Let's figure out what this ratio is. I have the sine of 99. Ooh, this is my first obtuse angle, isn't it? Divided by 9 point. This is my B here, and this is my A. And the A is clearly longer than B, so that is good. I think we have one triangle here. The ratio is 0.174. 0.174. 0.1074, sorry. So now we can figure out what beta is. The sine of beta is going to be 0.1074 times the length of the side times 5.5. So that's the sine of beta. Now we'll figure out what, okay, sine of beta equals 0.5905. So we're going to do arc sine of this ratio to figure out what beta is. Arc sine of 0.590465, etc. 36.2 degrees. 36.2. I'm going to add 99 to that, plus 99, and we've got 135. We're going to subtract or find the difference with 180. So I know that gamma is 44.8. 44.8. And we can figure out what C is. It's going to be the sine of gamma over C equals our ratio, which is right up here. So C is going to equal the sine of gamma divided by this ratio. Okay, so the sine of 44.8 divided by 0.1074. Let's say 6.6. Now, does it make sense? The smallest angle has the shortest side, the largest angle has the longest side, so it does make sense. Let's do this one. Now, here again we have, oh, maybe we don't actually even have to do anything here. We have obtuse, so we're looking at this or this. The angle opposite, excuse me, the side opposite the given angle is 16, and this side is 30, so we've got this situation. This is 30, this is 16. You know what? There is nothing. It's impossible because 16 is less than 30. So this is no solution.